Hi, welcome to my channel Programming Knowledge by Jagadish. In this video, we are discussing about data structure, the two stack implementation. In the previous, we discussed how to implement a stack using array. In this video, we are going to discuss about how to implement a stack using linked list. When we just go to specify implementation of a stack using linked list, first of all, we must know what actually the necessity in order to implement a stack using linked list than the array. The first and foremost here is nothing but when we are going to implement a stack using linked list, it provides a feasibility on number of nodes by dynamically growing stacks, which indicates when we are executing at the time of execution, at the time of running dynamically, we can add any number of nodes to a stack. We can add any number of values to a stack. Similarly, you can delete any number of nodes from a stack. It is not restricted that only these number of values are going to insert into a stack. You can add or delete dynamically, and the one more is nothing but stack can grow or shrink as the program demands to it. Based on the application, you can insert any number of values to a stack and you can delete any number of values from a stack. It is not restricted that only these number of values are going to insert to a stack. The major disadvantage of using array to implement a stack or a queue is nothing but wastage of space, which indicates, for example, assume you declare the stack size by means of array is 100, whereas you inserted only 10 elements or 15 elements in that stack. Then automatically remaining memory locations are waste. So that is what actually the disadvantage of using array to implement stack. When we are implementing stack, means performing operations on stack. To implement stack or performing operations on stack, definitely we must use a variable named as top. With the top, you are performing the operations on stack. So here, considering the same thing, that is variable top always points to the topmost element of the stack. By means of top only, you are performing the operations. Then here in the linked list, we are initializing the top value is equal to null. Well, in the beginning, which specifies stack is empty. When top value is equal to null, which indicates stack is empty, there are no elements in the stack. If we consider the previous one, using array, the stack using array, which specifies that the top is equal to -1 indicates the stack is empty. Whereas here we are initializing the top with a null when you are using stack implementation using linked list. Now, let us discuss about the stack implementation using linked list with an example. Here, see, there are totally of 5 elements are there. Those are nothing but 50, 40, 30, 20, 10. As we already know that top variable or top value will always point to the topmost value in the stack. That is nothing but 50. So now, in order to know what is the next value that is below of this particular one means, we simply reference the address of this particular node. The address of the particular 50 node is nothing but 1500. The second part address is nothing but 1500, which indicates below of 50 is stored in the address that is 1500. If we go through the 1500, then we will obtain 40 value. Again, in order to get the next value, again, we refer to the second part, that is nothing but this one, 1800, which indicates 1800 is the address at which the value 30 is stored. Similarly, after that, if you want to get the next value after the 30, we'll simply refer the second part of 30, which indicates 1200, which means 1200 is the address location of the value 20. Similarly, in order to get the next value 10, we'll simply refer the second part of 20 node, that is 1400, which is the address of the value 10. To get the next value, we refer the second part here. The second part is nothing much null, which indicates there are no other values after 10. This is what actually A simple example, in order to implement a stack using a linked list. When we just go to specify using a linked list, that stack using linked list will be appears like this. Now, programmatically, we discussed about how to implement a stack using linked list. As we already know that when we are working with a stack, the first and foremost operation is nothing but push operation, which is meant to insert a value into a stack. Now here we are implementing the push operation to insert a value into a stack. So for that to using linked list, for that here we just go to specify first declare one particular variable, that is nothing but a temp variable, pointer temp variable of struct node. Of struct node, which is nothing but a structure. Well, in the beginning we must define a structure. Now we must reserve memory to this temp variable or a temp node. So to reserve or create a memory to a particular node, there is a statement that is nothing but struct node pointer malloc size of struct node, where struct node is nothing but a structure. We must define a structure well in the beginning when we are working with linked list, what actually the node consists. Now, when we execute this statement, it simply creates or reserves the memory for the node temp. Now, the memory is created. In the memory, we are going to insert a value. So for that, again, here we are using a printf statement, which is for readable purpose. Printf enter data of item. So we have to enter the data of that particular temp node. So through scanf, we enter the data that to only one value, so only 1% LD. So here temp arrow data. Temp arrow data is nothing but the one statement which is used to insert a value into a temp node. To insert a value into a temp node, where temp node pictorially represents like this, which consists of two parts. The first part consists a data part, and the second part consists a link part. Now here in the data part, we are inserting some value like a 10 or 20 or 50 or whatever the value that you are provided as the input, that value will be stored here. For example, assume now I am providing 10 as the input, then the node will appears like this. Then next, we successfully inserted a value. Then what about the next? Temp arrow link is equal to top. Temp arrow link is equal to top. That indicates now here we are making whatever the value that inserted recently, we are making that particular one is nothing but a top one. That particular one is nothing but a top one. So simply top is equal to temp. The entire temp node will be act as a top node. The entire temp node will be acts as a top node. So this is the way how we just go to insert a particular value into a temp node using push function related to linked list. So this is what actually the implementation of stack using linked list. Similarly, now we go for the next one, that is nothing but pop function. Pop function is meant to delete a value from a stack. In order to delete a value from a stack, here we are using a function named as pop function. So to delete a value from the stack, first of all, make sure that whether the stack consists values or not. If stack contains value, then only we are able to delete. If stack doesn't contains a value, which indicates there are no values, which indicates we are unable to delete a element from a stack. Simply here we are going to perform that particular one using a statement, that is nothing but if statement. Here we are checking whether top is equal to null or not. If top is equal to null, which indicates there are no values in the stack. When top is equal to null, which indicates simply we are going to display that printf stack is empty. If top is equal to null, which indicates there are no values in the stack. If there are no values, we are unable to delete a value from a stack. So simply display stack is empty or stack is underflow. If this condition becomes false, then execute else part. Whenever the condition becomes false, simply it executes the else part. In the else part, the very first statement is nothing but temp is equal to top, which indicates, which means whatever the top that is pointed to so and so value, that value will be assigned to a variable that is nothing but temp variable. For what purpose means we are going to simply display, first of all, display the statement popped item is percentage d comma temp arrow data, which indicate that we are going to delete a value. We are going to delete a value which is assigned to a temp variable. For example, if a stack contains a multiple values, as usual, the recently added value is pointed by using a variable that is nothing but top. So in order to delete that particular recently added value, we first assign to temp, and temp arrow data that indicates whatever the value that is there in this particular part, in the data part, that value is going to delete. After deleting, we are going to specify the top value is the next of the previous one. So for that, we'll simply specify top is equal to top arrow link. Earlier, the link part is this one. Now we just go to simply assign below of the previous one and make it as the top one. Now after deleting the topmost element, below of the top is nothing but now the top one. So this is what actually the way to delete a value from stack. After deleting, simply use a function that is nothing but free of temp. Free is nothing but a function which is used to release a memory, which was created earlier. This is nothing but simply deletion of a value from stack using linked list. Similarly, there is a one more function named as a traversal function, which is meant to display all the values in the stack. In order to display all the values in the stack, we use a traversal function or a traversal operation. Here we are describing that function or operation by using a function named as display, which is meant to display all the values which are there in the stack. So for that, again declare a variable pointer temp of struct node data type, then simply initialize temp is equal to top initially. Before going to display, make sure that we must assign top value to temp. Now check whether top is equal to null or not. If at all, if top is equal to null or top contains a null value, which indicates there are no elements in the stack, which indicates stack is empty. If there are no elements or stack is empty, we are unable to display the values that are there in the stack. If the condition becomes true, take the next case. What happens if the condition becomes false? If the condition becomes false, it executes else part. In the else part, the very first statement is nothing but print of stack elements. Simply it is for readable purpose. We are displaying the statement like stack elements. And now after displaying this particular printf statement, come to the next one. Here we are checking a one more condition using while loop, temp not equal to null. This is a looping statement which indicates the following statements are going to execute continuously until unless this condition becomes false. Until unless this condition becomes false, the following statements are going to execute. For that, here we are using a while loop statement. Temp not equal to null. For example, assume that well in the beginning, temp value is not equal to null, which indicates it is pointed or which stores some value. Whenever it is not equal to null, which specifies there is some value in the temp, will simply display that value. Will simply display that value using printf statement. So printf percentage d comma temp arrow data, which indicates we are displaying some value which is pointed by top, because well in the beginning we initialize the top value by top value to temp. So temp arrow data, which indicates it displays the topmost value. Then to move from topmost to the next one, here we are using the statement that is nothing but temp is equal to temp arrow link, which indicates we are moving from topmost to the next element. For example, assume that if it is the stack is like this, for example, stack consists the topmost value 10 and the next is nothing but 20 and the next is nothing but 30. If it is like so, first we'll display a 10. After displaying 10, we have to display the value 20. To display the value 20, we must make to move a pointer from 10 position to 20 position. For that, here we are using a statement like temp is equal to temp arrow link to display 20. Again, after display 20, again in order to display 30, again we are going to make a move from 20 to 30 by executing a statement temp is equal to temp arrow link. Simply, this is a statement which is meant to travels to move from one value to another value. When it is moving value by value at each and every time, it is checking whether the temp contains a null value or not. If temp does not contains a null value, it displays a value. what is there in that particular stack. If at all, consider the next case. If temp contains a null value, which indicates this condition becomes false. When this condition becomes false, it simply comes out from the loop and it terminates this display function. This is the way how the number of values that are stored in the stack are displayed. These are nothing but the functionalities that we can perform on stack. Those are push, pump, and recently what we discussed is traversal. Thank you.